Here we are, day 3, lesson 3. Let's dive in. This time we're going to be comparing positive and negative numbers. Excuse me, man, already coughing. Don't get any ideas, I'm not sick. We need to make sure we understand these symbols before we go any further. I hope we remember these symbols from 5th grade, 4th grade even. I think you learned them. Let's review. This symbol right here is the less than symbol, okay? This one right here is the greater than symbol, okay? So make sure, if you don't have those memorized, write those down right now, because you're going to need to know those throughout this activity and several more in the next couple of days. So make sure you write those down somewhere so that you can always try to memorize those, okay? So now we're ready for activity 1 here. Which one doesn't belong? Which inequality does not belong? Okay, so this says that 5/4 is less than 2. 8.5 is greater than 0.95. 8.5 is less than 7. And 10 is less than 100. Now, we've done which one doesn't belongs a lot. And you already know, I bet, that there's no right or wrong answer on this because there's a lot of reasons why one or another one might not belong. So I want you to take a couple of seconds, if you haven't already done this, to decide for yourself which one you think doesn't belong and see if it matches some of the ideas I have. Because you know what? There's no wrong answer on this one, okay? So the first thing I noticed when I was going through this is actually some of these are wrong. Did anybody else notice that? Some of these are just flat out wrong, okay? So the first one I noticed that's just wrong is that 8.5 is not less than 7. 8 is bigger than 7. So the first one I chose was this one because it's false. This one, 10 is less than 100. That's true. 8.5 is greater than 8 is definitely greater than 0, so that is true. And 5/4 is 1 1/4, and yes, that is less than 2. So that's one thing I noticed right off the bat is that that one is false, and it's the only one that's false. So that makes it not belong, right? But being false isn't the only thing we could say here. One other thing I noticed is that this one over here is the only one that has a fraction. All of these have whole numbers or decimals, but this one is a fraction. So I could say this one because it's a fraction. It's the only one that's a fraction, right? Now, are there other things here? Well, yeah. I noticed that this is less than, this is less than, and this is less than. This one, though, is greater than. So I could say that this one is the one that doesn't belong because it's the only one that's greater than. Right? Now, can we come up with something for this one? It is true that 10.00 is less than 100. It is a decimal, but so are these. You know what I'm noticing, though? It's the only one with unneeded decimals. Do we actually need those 2 zeros? I don't think we do. So we could even say this one doesn't belong because it has unneeded decimals. Unneeded. I don't even know if that's a word, but that's okay. Unneeded decimals. So look at this. I've come up with a reason for each one of these to not belong. So again, is there a right or wrong answer? No. It's just practicing our observation skills, noticing details about symbols, details about numbers, and understanding what things mean. That's the point of this activity, okay? Number 2, comparing temperatures now. Here are the low temperatures in degrees Celsius for a week in Anchorage, Alaska. Well, I know a little bit about Alaska, and I know it's cold, so I'm expecting cold temperatures, and yep, that's what we've got in this table. Wow, that would be a rough week. Look how rough. Those are some cold temperatures for a whole week. First job here, plot the temperatures on a number line. Which day of the week had the lowest temperature? Now, when we're dealing with temperatures, I like to do vertical number lines, just like a thermometer. If you don't care, then neither do I. I don't care if you do a horizontal number line, because we can certainly do that. But I'm going to do a vertical one because for temperatures, I like temperatures on a vertical because it reminds me of a thermometer. Just like yesterday's lesson when we talked about the thermometers. Remember those? So I'm going to put a vertical number line here. And it looks to me like there are some positives and some negatives. So we need to maybe put 0 in the middle. So we have plenty of room above and plenty of room below on our number line. Okay. Now I also noticed that these numbers are not terribly huge. I bet I could count by ones. 1, 2, 3, 4, 5, 6, 7. And that would probably be big enough. 1, 2, 3, 4, 5, 6, 7. Because nothing goes bigger or smaller than 5, does it? Actually, 5.5 is slightly bigger, but we went to 7, so we're okay. So now, let's put these on the number line. Monday, the temperature was 5 degrees. That's positive. So we're going to go 1, 2, 3, 4, 5. 5 degrees Celsius. Okay. -1 is Tuesday's temperature. So again, from 0, I go to -1. -1 degrees Celsius. And I'm only going to label those that I put on there just because it'll get too squishy if I try to name everything, right? -5.5. All right, on the negative side, I have to go down 1, 2, 3, 4, 5. Then half again. There's another half there. So in between -5 and -6 is where that is going to live. And I'm going to draw a little arrow to -5.5. Okay. Next is Thursday at -2. So again, 0, -1, -2. And it's kind of getting squishy here. So I'm going to do it over here. -2 degrees Celsius. Should have given myself more room, but that's okay. And then Friday is 3 degrees Celsius. So that's positive. So 1, 2, 3 degrees Celsius goes over there. Saturday warmed up to 4 degrees Celsius. Wow, that's not very warm. 1, 2, 3, 4 degrees Celsius. I'm going to label that on this side. 4 degrees Celsius. Sunday, it was exactly 0. Wow, so we just put a dot on 0, and that is already labeled, so we are good to go. Awesome. Let's double check that we've got them all on here. We've got 1, 2, 3, 4, 5, 6, 7 days of the week. 1, 2, 3, 4, 5, 6, 7 days of the week, or 7 points on our number line. So we know we got them all. But don't forget, which day of the week had the lowest temperature? Ooh. Okay, well, the lowest temperature is going to be the furthest down our number line. There's our lowest right there, -5.5. So what day of the week was that? Wednesday. Wednesday. So that we spell it right. There it is. Wednesday is the answer to number 1. Okay? Now, numbers 2 and 3 are also using this table. So keep this table handy. Let's go on to number 2. The lowest temperature ever recorded in the United States was -62 degrees Celsius in Prospect Creek Camp, Alaska. The average temperature on Mars is about -55 degrees Celsius. Part A, which is warmer? The coldest temperature recorded in the United States or the average temperature on Mars? Okay, so we need to compare. -62, that's the US, and -55, that's Mars. So which one is coldest? Oh, it says which is warmer. Okay, so which is warmer? Is -62 greater than or less than -55? Well, if we think about our number line, we're going to have to go down 62 or down 55. Which one's going to be further down? Well, -62 is going to be further down. which means it is colder. It is less than negative 55. Well, if that's the colder one, then Mars must be warmer. Holy cow. Mars is warmer. Right? Because, and here's our reason. Because negative 55 degrees Celsius is greater than, see how I flipped the sign? Is greater than negative 62 degrees Celsius. There's my reason. There's my final answer. Oh, and look at this. In answering that, we just answered part B as well. Right? An inequality to show your answer. There it is. Negative 55 degrees Celsius is greater than negative 62 degrees Celsius. Or we could have written this one. Negative 62 is less than negative 55. Either one of those is a perfect answer for part B. Look at that. Number 3 is next. On a winter day, the low temperature in Anchorage, Alaska was negative 21 degrees Celsius, and the low temperature in Minneapolis, Minnesota was negative 14 degrees Celsius. Jada said, I know that 14 is less than 21, so negative 14 is also less than negative 21. This means that it was colder in Minneapolis than in Anchorage. Do you agree? Explain your reasoning. Okay, well, let's look at these two numbers. If these were on the number line, if I started at 0 and went down to negative 21, I'd have to count 21 spaces, right? Do I have to go as far to get to negative 14? No, negative 14 is going to be actually closer, which means that negative 14 is actually warmer, isn't it? So it's not so much looking at the numbers. You can't just look at the numbers. You have to remember that negative sign means something. Negative 14 is actually warmer. So I'm going to say no, actually. Jada's wrong. And my reasoning is because negative 14 is actually greater than negative 21, which means it's warmer. Right? So you can explain that better in words, but that is the idea there, okay? Are you ready for more? This is our optional. How many of you honor students are doing those? I hope so, because these are really good ones, and they're tied right into what we just did. So I hope you are taking the time to do those. And if you ever want answers or help on those, email me, because I will help you. Just like I'm doing these, I will help you with those as well. I just don't want to waste the time because it is optional. I don't know how many of you are doing it. So, but if you want me to, I will start doing that, okay? So you just let me know. And the last activity is activity number 3. Let's dive into this one. Rational numbers on a number line. Number 1. Plot the numbers negative 2, 4, and negative 7, and 10 on the number line. Label each point with its value. Okay. Notice we've got a pretty naked number line right now. Right? So we have to be super careful. It looks like we're counting by ones though. They gave us that hint. So that's super handy. Let's start with negative 2. Well, negative has to go to the left. So to the left 2. There's where negative 2 lives, right there. I'm going to put a nice dot and a negative 2. Okay? 4 is a positive 4. So 1, 2, 3, 4. There's where 4 lives, and I'm going to label that. Okay? Negative 7. Again, negatives are to the left of 0. So negative 1, 2, 3, 4, 5, 6, 7. Negative 7 lives clear down there. And then 10. 10 is a positive 10. So we go to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 is clear over there. Now, I didn't even have to worry about the rest of the numbers. It's a lot less messy that way, so now I know where those 4 numbers lie on my number line. Okay? Number 2. Decide whether each inequality is true or false. Be prepared to explain your reasoning. Okay. Negative 2 is less than 4. Is that true? Is negative 2 less than 4? Well, look at here. Negative 2 and 4. Is negative 2 less than 4? Yes, because it's to the left of 4. So negative 2, that's a true, right? Negative 2 is to the left of 4. There's my reason, okay? Is negative 2 less than negative 7? Is negative 2 less than negative 7? Well, there was a big hint. The fact that I had to go to the left to get to negative 7. That makes negative 2 actually greater than negative 7, doesn't it? Because we know less is this way and more is this way. So more, negative 2 is greater. So this one is false. Negative 2 is right. Is to the right of negative 7. Okay? I'm going to circle those so they stand out a little bit more. Next one. 4 is greater than negative 7. 4 is greater than negative 7. Yeah, 4 is to the right of negative 7. So that is true. 4 is to the right of negative 7. So that is true. Next one. Negative 7 is greater than 10. Question, are negatives ever greater than positives? No, that's just silly, right? So that is false. Negatives are never greater than positives. Right? Because negatives are always to the left. It doesn't matter what negative it is, and it doesn't matter what positive it is. Negatives are always to the left of positives, right? So that's a big fat false. Okay? Number 3. Andre says that 1/4 is less than negative 3/4 because of the two numbers. 1/4 is closer to 0. Do you agree? Well, here's the trick here. Yes, 1/4 is closer to 0. But does that make it less? It doesn't. Notice 1/4 is a positive and negative 3/4 is a negative. Negatives, we just talked about that. Negatives are never greater than positives, right? So negative 1/4 or positive 1/4 cannot be less than a negative because that's positive. Positive cannot be less. So this is a big fat no. Positive. Positive. Oh, that's what I did. See, we all know Miss Hatch can't spell, so it's no big surprise. You can roll your eyes. I'll give you permission. Positive 1/4 is greater than. I'm going to write the words negative 3/4 just to point out that's the real reason right there, right? Positive 1/4, it has to be greater than negative 3/4. Okay? Number 4, doing great. Answer each question. Be prepared to explain how you know. Which number is greater, 1/4 or 5/4? And I'd say we just circle one, but then make sure we understand why. Okay? Which one is greater? Well, if this is 1/4 of an apple or 5/4 of an apple, which one has more? 5 is always more than 4. They're both positive, so 5/4 is greater. Okay? And you can say the reason why. There's lots of reasons why. We know that 5 is greater than 1 with the same denominator. We know that it's going to be to the right on the number line. There's lots of reasons. I'll let you pick what you write for that one. Part B is down here. Which is farther from 0? Ooh, they switched the words up on us. Which is farther from 0, 1/4 or 5/4? Well, if I'm counting on a number line, here's 0, and here's 1, and there's fourths. So, okay, split this into fourths. 1/4 comes first, right? 5/4 would be clear over here. So which one's closer to 0? Yeah, definitely 1/4. Oh, it didn't say closer to 0. It said farther from 0. My bad. Farther from 0. I got to read the instructions. Farther from 0 is 5/4. Okay? Let's see. Which number is greater? Which number is greater? Negative 3/4 or positive 5/8? And that's the key. Keep an eye out for those negatives and positives because greater, if I'm comparing a negative to a positive, it doesn't matter what they are. Positive always wins. Okay? So positive always is greater than negative. We just discovered that over here. Okay? Which is farther? Here we go. Farther from 0 once again. -3/4 or +5/8. Now this one we have to think about a little bit further because we have different denominators, so be careful of that. I'm actually going to draw a number line here. -3/4. Well, let's pretend these big tick marks are fourths, right? If this is 1/4, 2/4, 3/4, 4/4, this is -1 or -4/4, right? So -1, 2, 3/4 is right there. -3/4. Okay. +5/8 though, if I count these into fourths again, there's my 1, my +1. 1/4, 2/4, 3/4, 4/4, or 1. But this isn't fourths, this is eighths. So now I need to split each of these fourths in half again. So now I have 1, 2, 3, 4, 5, 6, 7, 8 eighths. And I'm looking at 5 of them. So 1, 2, 3, 4, 5. There's 5 eighths. Now we have to decide, and I hope we drew this carefully so that we could really compare. Let's actually make everything eighths because then it'll be really easy to compare, right? Because we know this is 1, 2, 3, 4, 5 eighths. So what is this? 1, 2, 3, 4, 5, 6 eighths. So which one's farther? Is 6 eighths farther or is 5 eighths farther? 6 eighths is farther, and that's that one. Okay? Awesome. Last one. Is the number that is farther from 0 always the greater number? Well, look at that. We just answered that unknowingly on this last problem. Our farther away from 0 was this -6 eighths. But 5 eighths is greater, right? So is the number that's farther away always greater? No. You can have farther away in the negative direction, and those will always be less than any number in the positive direction because negatives are always less than positives, right? So the answer to this is no, because negative numbers are always less than positive numbers. Distance doesn't matter. Okay, so if they happen to both be positive or both be negative, then yes, the numbers can tell you, right? But if you've got one and the other, then you have to go with which one the negative was always less. Does that make sense? Awesome. That is the end of the lesson. The only thing we have left is the summary page. Very short summary this time. Very easy to read through quickly. I encourage you to do that. One glossary term. What they mean by that is the positive sign or the negative sign. It also talks about the greater than symbols and the less than symbols and the greater than symbols. So that's what it's talking about there. But you can always check out that glossary to get a further explanation on the word sign. And that's the end of the lesson today. You've done really, really well this week. 3 days in, getting the hang of this Canvas stuff, getting used to me on these stupid videos. I know they're not the most exciting things in the world, but we'll try to spice it up. By the way, one thing I haven't mentioned yet that I want to. Sometimes I make mistakes in my math, and sometimes I don't even notice my mistakes. Now, it may be a typo, like a spelling error, or maybe I forgot a negative sign, or it may be an actual math error, but I'm going to offer something to you. If you find my errors in my videos, and you let me know of those errors, I will give you a bonus prize. That may be a homework pass, it may just be bonus points on something, it may be forgiving one of those quizzes, it'll depend. So it's worth a shot. If you find one of my mistakes in my videos, let me know so that you can win a bonus prize, okay? That'll help me make my videos better, and it'll help you pay attention and be vigilant in finding Miss Hatch's errors, because I know they exist. Even I am not perfect, okay? So go ahead and dive into your homework. Make sure you do that before you continue this video. And don't forget, as always,
do your best because you deserve your best.
Alrighty, homework time once again. I hope you've already done this homework. Let's just check it together. So if you haven't done it, go do it first. Don't just copy this down because that's not the way to learn, okay? Let's go through this though. For those of us that are done, let's do this. Number 1, decide whether each inequality statement is true or false and explain your reasoning. Number 1, part A. -5 is greater than 2. I'm going to write these down again. Less than and greater than. I hope we have those memorized. If not, jot them down again. Every time you write those down again, it'll help you memorize it. Okay? So -5 is greater than -2. Well, are negatives greater than positives? Nope. Right? Negatives are never greater than positives, so false, because -5 is to the left of 2 on the number line. Okay, so that's the main reason, is because it's to the left. Negatives are always to the left of positives, so that means they cannot be greater than. It's false. 3 is greater than -8. There's an answer of, that's an example of true. Positives are always greater than negatives. It doesn't matter what numbers they are, right? This could have been -400. 3 would still be greater than it, right? So 3 is greater than -8 because, again, 3 is to the right of -8. So that makes it greater, okay? Next one, -12 is greater than -15. Okay, here's where we have to be careful because they are both negative. So which one is greater than? Well, greater than means further to the right or further up, depending on the kind of number line you're using. So if -12, if I'm counting from 0 to -12, would I hit -12 first or would I hit -15 first? I would hit -12 first, wouldn't I? Because I'm counting -1, -2, -3, -4, all the way over, right? I would hit -12 first, and then 13, 14, I'm off my screen, 14, 15, 16, right? So -12 is actually to the right, so that means it is greater than. So this is true. -12 is to the right of -15. And for any of these, a great strategy to check your work is to draw those number lines, right? Draw them and take a look, okay? -12.5, my dog is going crazy again. I don't know what's up with him today. -12.5 is greater than -12. Well, if these were both positive, positive 12.5 would be greater because it's 12 plus a half. But we got to remember, when we're going in the negative direction, if I have to go to -12 plus a little bit more, that's actually further away than just 12 is. So this is actually false because -12.5 would be left of -12. Excuse me. I'm going to take a little drink of water real fast. I think I've just been talking too much today. All right. Number 2. Here is a true statement. So it says this is true. -8.7 is less than -8.4. I agree. That is definitely true. Select all of the statements that are equivalent to -8 is less than -8.4. All right, let's go through these. -8.7 is further to the right on the number line than 8.4. Well, if it's less than, does that mean it's to the right? Nope. That means it's to the left, right? So that cannot possibly be true. Part B. Negative 8.7 is further to the left on the number line than negative 8.4. There it is, left, right? So that's a yes. Negative 8.7 is less than negative 8.4. Yes, that's what that symbol means. So yes, that is also true. Okay? Negative 8.7 is greater than negative 8.4. Well, we just said that one's true, so this one cannot possibly be. Negative 8.4 is less than negative 8.7. Notice they switched those numbers. So, if 8.7 is less than 8.4, can 8.4 be less than 8.7? No, that can't possibly be true either. Is it negative 8.4 greater than 8.7? Here it is. They switched the numbers and they switched the sign, so that is actually true. Very, very good. So 3 correct answers on number 2. Did you get them all? Hope so. Number 3 has a table, and I bet the questions for this table are on the next page. Yeah, maybe not. Well, let's just read the instructions and see what's going on here. The table shows 5 states and the lowest point in each state. So this is the lowest elevation in California, Colorado, Louisiana, New Mexico, and Wyoming. Okay. Here we go. Put the states in order by their lowest elevation from least to greatest. So we need these numbers from least to greatest, but we're putting the states in order. So we're going to actually write these words in order from least to greatest. Okay. Now, I don't care if you do these vertically or horizontally. I think it'll be easier. I'm going to go vertically in order. Okay. Least to greatest. So we need the smallest number. The negatives we know are less than the positives. So let's start with the negatives. Which one of these 2 negatives is going to be furthest to the left? Well, if I'm counting starting at 0, I'm going to hit 8 real quick. But then negative 282 is going to be clear over there, right? So that must mean it's less. So California is our least. Our lowest elevation of all of them, okay? And then the only other negative left, that must be next. So Louisiana is next. All right, we've taken care of those 2. Now we look at the positive numbers. Which one's the least of those? Well, 3,000, 2,000, 3,000. 2,000 is less than both the 3,000s. So New Mexico is next. Done. Now, 3,300 or 3,000 right? That I don't even have to look any further. This one has to be less. So Wyoming is next and smallest, and the largest is Colorado at 3. Oh, not the number. The very end, I messed up there. Colorado is the highest, lowest elevation, if that makes any sense. So there, put the states in order by lowest elevation from least to greatest. There we go, least to greatest. We've done it. Okay? Very, very good. There's problem number 3 done. Number 4. Plot each of the following numbers on the number line. Label each point with its numeric value. All right, here we go. We've got a number line that's been started for us. Let's go ahead and add these numbers in. 0.4 or 4/10. 4/10 is positive, so it's going to be bigger than 0, but it's not going to be quite as big as 1. 4/10. Well, if I'm putting tenths in here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tenths. 4/10 would be 1, 2, 3, 4. So there's 4/10 right there, 0.4. Okay? Now, negative 1.5. Negative. So negative 1. Now, where does the 0.5? That's halfway, right? Half. So negative 1.5 lives about right there. I'm just going to eyeball that one. Negative 1.5 lives right there. Okay, now we're done with that one. Negative 1 7/10. Well, that's going to be quite similar to this one. This one is negative 1 5/10, if you think about that in place value. And this is 7/10. So if this is 5/10, we're going to go 6/10, 7/10, 8/10, 9/10, 10/10. So that's 5/10, 6/10, 7/10 lives right there. I'm going to label this one down below with a little arrow. -1 and 7/10 lives right there. Now that one's done. -11/10. Ooh. Well, 11/10 is one more than 10/10, right? Which is one whole. So this is -1 whole plus 1/10. 2, 3, 4, 5. Yeah, so we got that right. So -11/10 would live right there. -11/10. Okay, now we're done with all 4 of them, and we've got them all labeled nice and neat on our number line. Okay, number 5. Now we're to the review of units in the past. This is now from unit 6. See this? Each lap around the track is 400 meters. How many meters does someone run if they've run 2 laps? Well, if 1 lap is 400, 2 laps would be 400 times 2, which would be 800 meters. Okay? What if they ran 5 laps? Well, same idea. If they did 400 per lap times 5 laps, that's a times sign, then that would, 4 times 5 is 20, but I have 2 more zeros, so it's actually 2,000 meters. Okay? X laps. Now let's say we don't know how many laps. How could I figure it out? Well, what we've been doing is doing 400 times the number of laps. So wouldn't it just be 400 times X or 400X? It would indeed. Okay? If Noah ran 14 laps, how many meters did he run? Well, same idea. 400 times 14 laps, right? Let's split this up. Let's make this easier. 400 times 10 plus 4. Remember this trick from last unit? Let's practice it. 400 times 10 is 4,000. 400 times 4, 4 times 4 is 16 with 2 zeros, so 1,600. 4,000 plus 1,600 would be 5,600 meters. There's my answer for part B. I might have to do a little arrow over to that, right? Okay. So far, so good. Number 5, part C. If Noah ran 7,600 meters, how many laps did he run? Oh, so now we're going backwards. Well, let's take this idea and use it. We know that 400 times the number of laps equals how many meters total. And in this case, our meters total is 7,600. So now I just need to solve that equation for X. X is being multiplied by 400, so I need to undo that with division. So dividing by 400 on both sides will give us our answer. So X equals whatever 7,600 is divided by 400. And I think I might have just run out of lead. I've had a big chunk just fall out. See if I can get this back in real fast and not have to ruin my whole video. Oh man, this is wasting time. I hate it when I waste time. There, hopefully it'll work. All right, here we go. Oh, it's gonna fall out again. How many times does 4 go into 7? I'm just gonna try to do this mentally. 4 goes into 7 once. And then it has 3 left over, so now I have 30. 4 goes into 30. Well, maybe we should do the math over here. 7,600 divided by 400. Oh, goodness. Well, 400 goes into 700 once, which is 400. 360 left over. Bring down the 0. 4 goes into 36 9 times, right? So 400 goes into 3,600 9 times, which would be 3,600. So that's my answer. So 19 is my answer Except what does that mean? Well, that means that he ran 19 laps. And once again, I'm having to fix my pencil lid. I'm being stubborn and I don't want to stop my video to go get more lead. Oh, I might just have to. Okay, so this last one, he ran 19 laps. Maybe I can just find a new pencil really fast. I've got to have a new pencil here somewhere. What a waste of a video time here. Okay, sorry about that delay. Oh my goodness gracious. So 19 laps is our final answer. 19 laps. Okay? Number 6. A stadium can seat 16,000 people at full capacity. If there are 13,920 people in the stadium, what percentage of the capacity is filled? Explain or show your reasoning. So I have 13,920 people out of the total of 16,000 people. This is kind of like a grade, right? If I earned this many points and this was the total, I could just do that division, right? So I can just divide 13,920 by 16,000. Now, that's going to be a decimal. It's going to be 0 point something because that won't go in even once. So I have to add another 0. This is going to be ugly. Well, if I think of 16 into 139, 16 times 5 is 80. We can do better than that. 16 times 7, that's 118. Let's keep going. 16 times 9, that's... Oh, that's too many. So 16 times 8, I think, is what it's going to be. 6 times 8 is 48. 8 times 1 is 8. 9, 10, 11, 12. 128,000. Okay. So now I subtract. Okay. Now 16 into 112. Oh, I had to bring down another 0. 16 into 112. Well, we got real close over here. Ooh, 16 times 7 was 112. Nice. So I'm actually done. So what is the answer? 0.87. Well, we need that as a percentage. So that is 87%. Very good. And we showed our reasoning, so we don't have to explain because it says or. So what percentage of the capacity is not filled? Well, filled is 100%. What we've done is 87%, so we just have to subtract that. So the percent that's not filled is going to be 13%. There's the answer for part B. And I believe that's the end of our homework. Yay! That is the end. So we're done. Any questions? Make sure you email me. Good work. I hope you did well on this homework assignment. It's harder doing it at home, I know, but I hope that my little videos are helping you understand and stay on top of things. Next, your job is to do that. Check your understanding quiz because that's what's going in Canvas. So jump over to, or into Skyward. Jump over to Canvas and do that quiz so that you can get the points on your grade in Skyward. Good luck with that. Don't forget to always do your best. Because you know why.
Because you deserve your best.